During last month HyDraw webinar, I've been drawing this part of a schematic. It was a portion of a test bench diagram. And if you remember, for those who attended also to the other webinar, I was saying I will start from here. I will build something more starting from here. So today's webinar, I will be, as always, try to explain a bit of commands or interaction that we have in HyDraw CAD, but trying to make something realistic for the hydraulic industry. So today, as you can see from this diagram, I have a lot of components, but not model codes, no manufacturer. So I will try to use some interactions that we have in HyDraw CAD with Excel file. So I'll show you a big list of model codes and how I can interact with that. And also I will show standard HyDraw CAD command. So for those that are new to HyDraw CAD, I just start with a new diagram. So when we are in the start menu, I click start drawing, or always in the start menu, you can select a template. And I have my custom template. I've been showing how to create custom template in other webinars. If you need more information, you can ask, or you can find a lot of videos that have been already published there. Now, my template is customized, so I already have paper space. It's easy to plot. I will just put a title block. So moving to the system tab. And so for those who are new, HyDraw CAD is basically built around an AutoCAD OEM engine, which means you don't need to buy AutoCAD. You get the AutoCAD license included in the software. These that I'm highlighting are standard AutoCAD menu, drafting, insert, annotate, parametric, 3D tools, and you can use HyDraw CAD as a standard 2D drafting environment. We developed a circuit system and services tab. In the system tab, basically we extract information from what we do. In the circuit tab, we insert symbols and do some other stuff in the diagram. In the system tab, we find also the insert title block. So let me just insert the title block. I need an A2 page, and that's it. If you need to fill in attributes, so just click edit title block and you will be able to apply this attributes change. So created by myself, CM, and the title is test bench. So the part of diagram that I'm going to build today is linked to the other diagram. So it's made, so in the other diagram, let me get back here. We had a pump, a variable piston pump with a pressure control, and the power source is going to a page of the sheet 2. So I'm going to start from this power source. So I will connect, and I'll need a pressure reducing valve. So as you can see on the left, we have a HyDraw Library Explorer, which is divided into several folders. You find a lot of symbols inside each of these folders. And in this case, I'm looking for a particular part number. So I'm looking for a proportional pressure reducing valve. So I'm going to search, instead of searching for symbols, I click on these 3 buttons and I look for a R4R, which is a Parker pressure reducing valve. I'll take this symbol, double click and place my pressure reducing valve. This valve is linked to the other part of the diagram, but before we have a filter and we have a check valve. So let me keep doing some insertion from data from component directly. Then we switch to how we find only the symbols. So as you see here, if you know the model code, so if you know what you're looking for, then it's easy. You type in the model code or part of it, and then you start from the result. Let's say that now instead of searching for a particular model code, I want to search for a particular manufacturer, let's say Bosch Rexroth. I need a check valve, skewing cartridge, and I just do a search, random search. There will be a lot of check valves here. I'll take an MSR, industrial valve, double click and place my check valve here. Now HyDraw is asking me which item, which size. So we have a size 10, size 15, 20, and so on. So my system is rated about 120 liters per minute. So I'll take a MSR 20, insert in my drawing, and I place in my drawing. In addition, I need a filter. I want a pressure filter. So I go back, and now instead of searching for a part number, let me just show you how to look for symbols. So I go back, I click this close tab, and although I know that we have a folder for filter, but if you are looking for particular symbol, you can just type in. So if I just type filter, I get directly only to the folders that include filter symbols. So I'll take my single and I add, let me take a symbol with check valve and also pressure gauge. The symbol is not properly rotated, so with a right click, I can flip it vertically. So HyDraw will take care of symbol orientation and so on. When we select the symbols, we can move attributes all around. And let's say that I put this symbol here and move it up. So the system is AutoCAD based. So if you are familiar with AutoCAD, you can use the command line, press M for move, and start point and end point. If you are not familiar with AutoCAD, please remember the easiest way to move a symbol is you select it, take the insertion point, and move it. Working with the grid is helping because we can keep easily vertical or horizontal alignment. Let's start making our connection lines. So to make connection line, we go to the circuit tab, and I'll start making a pressure line that is coming from the other part of the diagram. And then with enter, I keep doing connection lines. And now my connection line, I make it going up. Later, something else will be added there. So this line is coming from the other diagram. So I will add a jumping reference to this line. The jumping reference is P, and it's coming from the first sheet, P1. There is actually, I'm working in two different files. So what I have made here is only a link that is not really a physical link between the two files. The link will work if you do jumping reference in the same DWG document. But now my choice was to make a different DWG file. So this link is only graphical. There is no direct link between the two files, two different files. Now, my system is supposed to be a test bench for a servo valve. So I'll just take a servo valve symbol, and I take just a standard one, not so complicated. This one is good, and I place it here. Now, as you can see, the connection line is not done there, so we can take the end and move it on the connection, but this is making inclined the connection. So in order to make a correct horizontal and vertical line, in this case, we use the HyDraw stretch command. So stretch command is very powerful because it allows us to do some modifications. So you take the horizontal segment or vertical segment, and you are able to modify the way the connection line is going. As a test bench for servo valve, this is just a placeholder. We are not willing to use this in a part list. So I'm going to remove this item from the part list. So by clicking exclude from part list, the balloon is not showing anymore in the diagram. So this helps when you want to describe an item that is not really part of what you are supplying, but you want to give the idea of what you are doing with your system. My system has also accumulator, so let me find accumulator. I take a bladder accumulator and I put it here, and I want to connect directly here. Usually we don't connect directly accumulator, maybe at least a shut-off valve. So let's find a shut-off valve. We take flow control, shut off, line mounted, and with a double click, we place a symbol. We can place the symbol directly on top of a connection line, and this is breaking the connection line into two segments. There is also an accumulator on the other side. So we are making the tank line, and instead of auto connect, so I highlight every time I do the webinar, I highlight the auto connect behavior. Honestly, this is not my preferred way for drawing. Although auto connect is handy because you click the connection line and you just select start point and end point, and then HyDraw will try to make the connection as it finds reasonable. But as you can see, as an example, although this connection is not correct, is not what we want to do, but in this case, the connection is going through a symbol. So I normally like to work with manual connection mode, because there I have the flexibility to do the connection where I want. So now I'm taking a tank line, and you just click, 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 and make the connection as you want. I use the drain for the pressure reducing going also to the tank line, although sometimes we keep separate drain. As you can see, I have already a dashed line because I selected the drain type of connection. If you already have a connection line in the drawing and want to change the type, you can select, and on the right, on the property manager, so here, this is going to be pressure or control, or let me take a pressure connection line. So we have a command that is helping with finding mistakes in a diagram. Although normally when we print the diagram, it will be black and white. So the fact that this connection line is orange, the other is blue, is not really making much difference. If we go to the System tab and click the schematic check, and in this case, I want to check just the connections. Later, we'll see the other checking. In this case, I have some warning. So this tank connection is hanging. So, and there is also a warning flag here. So I didn't put a jumping reference. It's a connection line ending nowhere. So most likely it's an error. Then I have this valve that has A and B not connected. Yes, I didn't connect. So it's correct that HyDraw is highlighting as a potential mistake in the block, in the schematic. But also in this case, it's highlighting that I have a connect in a pressure and a tank line, and it's here. Again, as I said, when we plot, there will be not much difference, but it's better to keep the correct attributes to connection lines. Also because if you already know, we have a software for making manifolds that is taking this information into consideration, if it is a pressure line or a tank line. So it's better always to assign the correct line type. So this is a drain line. For a faster operation, you can select, right click, and go to connection and select a different connection line. As you can see, there are a lot of other connection types. Pressure, reservoir, control, drain, and working are the standard ISO 1219 defined connection lines. By default, we have additional 5 or 6 lines. Electric wire is a line that I have created in my library. So you can create additional line types with different styles and different colors and layers directly in the library manager that comes with HyDraw CAD. Let me put again a jumping reference here, and that's my tank, and it's going to page 1. This valve will be connected to a cylinder, so let me find a cylinder. Double acting, so that's my double acting cylinder. And I'm going to make connection lines now. Working line, so in this case working, because we don't know if it is a pressure or tank, so it can be tank and pressure according to where it's going the flow. Although with a servo valve there is always high pressure drop, so basically we always have pressure lines in both ends of the side. I want to copy these entities because my test bench has 2 positions to test. So I want to right click, copy, and position here. As you can see, automatically HyDraw CAD has number 6 and 7. So the way HyDraw CAD is numbering items depends on the fact that if we have a part number or not, if we have a molecule or not. So for instance, in this case, I have a shut-off valve. So when I select a symbol, on the right, I have all the information related to that symbol, and I have this small command. It's very small. Select library, and I'm going to select from Fluid Power Tools. So I can search online a shut-off valve, inline shut-off valve from all the manufacturer. This is a very generic search in Fluid Power Tools. And Fluid Power Tools is the database from which I took that pressure reducing valve and also the check valve. I have a lot of manufacturer. Let me take a Gemals, Italian brand. We can open a datasheet if we want. And let's say that I take this one, GS6, DN20. Now let's take a small one, DN13. Now, as you can see, I have selected from the online database some information. So this symbol has now become a GS, whatever it is. So if now I want to copy, select, right click, copy selection, and copy these items, now this is coming 5.1 and 5.2. So HyDraw CAD automatically recognizes if you have identical items in the drawing, and in that case, it increases the grouping. The way it increases, so I like to show 5.1, 0.2, 0.3, and so on, but you can customize. In the HyDraw options, under Item ID, you have several settings that allow you to customize the way the grouping is made. So we have dot as separator and numeric. You can use the none as alphabetic or dash and so on. I use dot as numeric. There are a lot of other customization possible here. So this is not really a training. I'm just giving you an overlook of what is doable. But as you can see, we have automatic numbering, and we can number hoses. We can display accessory or assembly IDs, and so on. Let me move this symbol. Well, let me flip it horizontally and move it. We have improved the connection, as you have seen now. In the past, HyDraw CAD was creating a loop in the connection. Sometimes still it may not be always on par of what you expect. Still, you will always be able to delete connection line and do again, or modify connection line by using the stretch connection command. I see a question, so let me try to answer. So the question is there advantage in using the property manager versus the explorer when searching through Fluid Power Tools? That's a good question, and it depends on where you are starting from. So if you already know what you are looking for, it's better to start from the Library Explorer because you have several options. Let's say that I need a relief valve. I want Parker, so I can select the manufacturer. I know that I'm looking for Parker, and I need a screw-in cartridge relief valve. Screw-in cartridge, which is rated 30 liters per minute, and search. Then I will find, well, this is a solenoid operated. Okay, that's fine. I'm finding for Parker all the items that match this criteria. So I place a symbol and already with model data. So if I know that I'm looking at a specific component, it's better I start searching here, because the challenge otherwise is how can I find this symbol in a 20,000 symbols library. But if you know that you need a relief valve skewing cartridge. So if we go in the skewing cartridge, pressure control relief valve, and I need a direct operated 1 to 2 or 2 to 1, depending on, but as you can see here, the choice can be differential or direct operated. At this choice, we condition what you will find at the end. But now I need a direct operated relief valve. So now the symbol is there, but I have no model data. So I will select from library and search in Fluid Power Tools. At the end, you will always be able to retrieve information from the same library, but it's a different approach. If you know which model code, then it's very easy to do a model code search. 4W6J search, and you find it directly straight the symbol without looking for that particular symbol. Or on the other hand, you can say, I want a replacement for this symbol, and then you click show link the model. And then you find the equivalent for Argo-ITOS. You can, and we can filter, let's say that I need a Have SVP1D. Double click, and I place my symbol. So sometimes I find it handy to select first, but then if I need to change, I must do from the library. Now Fluid Power Tools is automatically searching for SWP, which means I don't need this family, I want to change it, and I can search. Now the search is from the symbol in the library with all the possible valves from all the OEMs that will match that particular symbol. And there we can filter by cavity. Let's say that I need DO3, and we find Eaton, Rexor, Parker, Diplomatic, Argo-ITOS, Vanflu, and so on and so on. Since we are speaking about model data, let me save this and I'll jump to how to populate data. So this is my test bench. If I'm unable to finish today, we'll go on during next webinar. I'll mix a bit. So we have seen how to find symbols, how to find components, how to do some connections. Let me get back to the power unit because I want to show you a bit of interaction with Excel. Let me start from the Excel file. So let me open my big model codes table. It's on a different screen. Okay, so this is a big table. I mean, it's made randomly. I keep adding items according to my need for training. So as you can see, and really it's not important how you structure the Excel file, but it's important that you have columns and properties. In my case, I have a model family. It's handy to have a model family because it's grouping identical equivalent items. I have a model code, which is how the hydraulic industry is recognizing items. And then we have description. I also added a Italian description because sometimes we need to make documentation in multi-language. So why not having a dedicated attribute for a French description, German description, Swedish description, and so on. I have a manufacturer. I have a part number. So this is really a randomly generated numbers, not realistic, but just to show you how we can do it. We can also add list price and other attributes. I have voltage, displacement, rated pressure, rated flow, and so on. So we can have HyDraw look inside this table. This table is made of something less than 1,000 items, but it will work very efficiently for much larger data set. In order to have HyDraw read this table, we need to do two operations. The first operation is we need to program HyDraw to be able to read that file. So to do that, we need to run the import. It's called Excel interface. HyDraw update from Excel 2021 or 2020 if you are using older version. So this utility will be able to read the Excel file. Now it's reading the Excel file. It's finding the sheet in the Excel file, and it's finding all the different columns in the Excel file. So let's say that I want model family, model code, description, manufacturer, part number, and displacement, rated flow, and rated pressure. You can select which attributes you want to read next, and automatically you get some mapping. In this case, my model family is not mapped, so I can map the property and select the model family. So here we are doing the mapping with the equivalent HyDraw CAD attributes. When I click OK, this interface, this utility, is creating an XML file that is stored in a particular location where the Excel file is located. Now what we do, so this is the first operation we do. The second operation we do is we go to the options, application settings, and we tell HyDraw that in the update from Excel, we want to search for that particular file. It's the one that I was looking for. And I'm searching by model code. You could be searching by part number as well. So when I define this, then HyDraw is ready to take information from that Excel file. Let's see how it works. So if you remember, my Excel file has a big list of item number. So let's say that my pump is a Have V30D, V30D. And I don't want to spend time in looking for a model code, model family. I know that it's a V30D, and I want to search it if it is available in my Excel file. So I will run update from Excel for this symbol. I will say include all. It's unable to find exactly a matching model code, but I can select, and it's finding a model family with a particular model code, a ERP number, and a displacement. So I click OK and update. Now my component, and as you can see, it has changed also the displacement. Now my component becomes exactly a V30D with a pressure control with a remote pressure. If I do the same for the other pump, let's say in this case it's a Eaton 45 VQ, I can do the update from Excel, again, include all, and I'm finding another item, only one in this case. Let's do something more complicated. And again, now this is changing the displacement and showing me exactly the item number and so on. Let's go to this relief valve and let's look the search from Fluid Power Tools here. So I need to find, I want to use industrial DBD Bosch Rexroth valve. So I look for DBD for Bosch Rexroth. And I get a list of available. Let me take a DBD 20K. Okay, so now this is my item and it becomes a DBD 20K. There are other relief valves in my system. So this one, I want it to be identical. So I want to copy this valve with this one. Okay, so now they are identical, DBD 20K. But as you can see, there is not exactly that particular, the model code, because a letter is missing. I don't know if it is a screwing cartridge or if it's a fixed setting or not. And I don't have also the setting. But that information is available in my Excel file. So let me run update from Excel on these two items, including all. And I can select, and now it is finding 4 different items. So let's say that I need the 400 bar. Okay, and update. So now I have fixed my exact model code. Let's do the same on the filter. I need a filter DF HIDAC, and I'll update from Excel. And then I find a particular pressure filter with a dedicated part number. Update all. Now my filter has a complete model code. So I can copy. I use the same filter on the other pressure filter. Okay, so I do it again. I show you. This copy is very interesting. Copy. Copy command is copy properties is a very useful command that helps you with copying attributes across different symbols in the drawing. You can use to copy a datasheet, a model code, part number, a cavity, or whatever. Usually, I use it to copy to make two equivalent components. So in this case, let's say that this valve, I don't need this view CN, which is a mobile valve. I want a MSR valve. So I go into my search and look for an MSR in Fluid Power Tools, search. This search, although I have not specified manufacturer, will find only Bosch Rexroth valves. And let me take a size 20. So now I am changing data structure for here. And like I did, update from Excel on this symbol, including all, and select. So I need an MSR 20. And let's take a 0.5 bar update. At the same time, we can do that for this was a PMVP HAVE valve. Let's say that this one is a CMV, always HAVE. And this one, let's look online, what's available. Let me take a HIDAC. And let's run now again, update from Excel on all these three symbols. So now the selection in multiple. So you don't need to run update from Excel only one at a time. You can run simultaneously on a selection. So I find this complete model code from HIDAC. And this one, there are several proportional relief valve. So in this case, my Excel file has also the rated pressure. So this is interesting because it helps me with defining which I need X12, so 12 volt. And the CMV as well, I'll use the rated pressure. Let's take a 500 bar. Update all. Now all these items become completely defined. My part list had already been created, so now it is asking to be updated. So we can select, right click, and update the part list. So now in this case, we have a ERP number and additional items. This field is very long, so in this case, sometimes it happens that the model code is not fitting. So you can just do a small change in that particular cell if you want, or just leave with a different size in the columns, or you can just extend. In this case, then, if you do something like this, which is not nice to see, you can then move, and this will stretch the size at the minimum possible. Now my table is not fitting, but I'll make it. I'll find some room for it. So, and this is okay. Right click, move. So this table is an AutoCAD table that we have in the drawing. You can control the size directly in the HyDraw options, application settings, list and charts. And here you have all the size, standard width for each column. But of course, then if you need, you can change in the drawing. So as you have seen, the ability to link with external data sources is interesting because at the end, what you want to do is that the formation of the symbol in the drawing are matching what you really do in your part list. So if the model code are not already in HyDraw library, but are somewhere else in your ERP system, then you can extract from your ERP system all the data, like an example, the Excel file that I have, and start taking information from there. Then when we are in HyDraw CAD, now that this is a complete model code, I can save it to my library. Also, this proportional valve, I can save it to my library. And the other HIDAC valve, I can save to my library. And the filter, I can save to my library. And the DBDS, save to my library. And also this pump, save to my library. So now I am also building my local database, so that next time, instead of looking online or manually filling information, I can do all my search in my corporate database. And now I can search for the DF. And as you see, I'm finding directly the pressure filter that I had placed. Or if I look for the PMVP4, I can search and I find directly that proportional valve. I see some questions, so let me go through. So let me read this question. Would be the Excel link the best way to develop a database that is specific to a company department? Again, that's a good question, and it depends. It depends. I find the Excel link the easiest and fastest way to start immediately using HyDraw and having a part list that is matching your need. So if you have time to populate the library, then it's better to populate the library with Excel and go directly in the library manager. But if you need to produce diagram, which is most likely the case for everyone, we need to deliver, then linking the Excel file is probably the best way to get it growing with usage. And then, as you have seen, we save the information to the database. So then the question is, will that database continue to be built? Yes, so as you understand here, I'm placing a symbol. Let's say I need an MSR, a DBD. I'm placing a component. I need to change it. I need to update from Excel this one. Well, let me select a generic one, otherwise DBDS20. I update from Excel. I read the additional information, 400, and then I save to my library, save. So I'm building the library live. Now this model code is already in my library, so that's it. I don't need to save it again. So I'm building on a daily basis the library with what I need on my daily project. Let me go to the other questions. Okay, I see a question. It was already solved, replied, but let me reply to all the attendees. So let me add a new item to the diagram, a symbol here. So this is item 12. The part list has no item 12, and the part list is not asking to update. Update part list, actually it was asking to update the item number, because when I placed that DBDS, it increased that item number. So when you add an additional component to a schematic that has already been a part list, you must recreate the part list. I've been asking an enhancement, and hopefully we will address sooner or later. I want at a certain point in HyDraw to be able to maybe right-click and add the symbol to the part list and touch additional symbols. Now it's not possible, so what you must do is you delete the part list and recreate it. So unfortunately, when you make a part list and you add additional components, then the part list must be recreated. It's very easy to recreate and fast, so that's why it's important to define the correct size, so that you don't waste time with moving the part list all around in the drawing.